Hi, Earthy. We're going to take a look at page 70 in your review book. This is essentially questions 28 through 40. Okay. So for number 28, traditionally most units of time are based upon this one. I thought to myself, ooh, I could see where there could be two possible answers to this. I knew that time was not based on the motions of the moon. We haven't even talked about the moon yet. And it couldn't be the real motions of the sun, because we know the reason we see the sun move is because of the Earth's rotation. So right away we can rule those two out. Some people said that it could be the longitude of the observer, which is true, right? But if the Earth did not rotate, then the longitude you wouldn't have different time at different longitudes. The whole reason we have different times at different longitudes is because the Earth rotates. So the best answer here is number one. Okay. Number 29. If Earth's rate of rotation decreased, so in other words, if we slowed down, what would happen to our days? We would have an increase in the length of a day. So if Earth slowed down, our days would get longer. That's essentially what this is saying. Because remember, rotation is a daily change. And so that's why it's got to be the Earth day. Okay. It would not be the length of the seasons. That's because that would be a yearly change. It would not change the angle of our insolation. That's due to our tilt. So the angle of the sun's insolation, that would change if our axis tilted more or tilted less. The number of observable stars seen at night during the year, well, that's only going to change if we get more stars, or maybe if we had less light pollution in New York City, then we would see more stars. But that's not going to change if the Earth is revolving or rotating. Okay. Number 30. How long does it take Earth to complete one orbit around the sun? Again, you need to know that one orbit is the same thing as one revolution, and that takes 1 year. It takes us 1 year to go one time around the sun. Okay. Number 31, units of time are based on Earth's motion relative to other celestial objects. Celestial just means sky objects. The year is best defined as Earth's motion relative to well, if we're talking about a year, it's Earth revolving around the sun, right? And so the correct answer should be number 2, sun. All right, let's take a look at number 32. According to the diagram below, the time at point C is closest to, okay, where's point C? All right, here's point C right here. And we want to know the time. So now this is the first time I looked at this, I thought, well, how am I supposed to figure this out? They haven't given me some other reference point to figure it out and compare it to, right? But if you look, you can see that this half of the planet is all in shadow. It's all shaded in, whereas the left side of the planet is not. It might be a little difficult to see on here, but hopefully you can see it on your review book a little bit better. So it's day on the left-hand side and it's night over here. So day on the left, night over on the right-hand side. So that means that if I'm at point C, I'm right at the boundary, like right where either the sun is rising or the sun is setting. So it can't be 12 noon and it can't be midnight. I know that. It's got to be either 6 a.m. or 6 p.m. How in the heck do I figure out the difference? We have to remember that the Earth is rotating counterclockwise. And if it's rotating counterclockwise, that's based on whether or not I'm looking at the North Pole. So if I'm looking at the North Pole, which I think I am, because let me clear this. Because if I look here, I think this outline right here is North America. I'm pretty sure that's North America because I can see Mexico right here. Okay. And I think this right up here is Alaska. So I'm pretty sure that that's North America, which means point A must be the North Pole. And so I know that I have to be going counterclockwise. And if I'm rotating counterclockwise like this, that means that point C is going into the darkness. It has left the daylight and it's going into nighttime, which means it's got to be 6 p.m. So that's how I figured that out. You did not have to do number 33. I believe we went to 35. So number 35 has to do with this diagram here. Okay. The first thing I notice, it says some of the latitude and longitude islands in label. Point A represents surface. Okay. First thing I notice, though, on here is that half of the Earth is in shadow. And the sun is over here, right? So big old sun over here. And as soon as I see that the North Pole and the South Pole are split, I'm like, ooh, that's an equinox, right? Sun is aimed directly at the equator right here, so it's an equinox. I mean, it might not help for this question, but it's just something that I notice, and you should start to notice that as well, right? So number 35, what do locations A, B, and E have in common? Let's see, here's A, here's B, here's E. Aha. Well, they're all along this same line, right? That is a longitude line. So that is what I think of when I see that, right? So they're all on a longitude line. Are they all going to have the same season? No, because A and B are in the northern hemisphere. E is down here. So when B is experiencing spring, E is experiencing fall. When B is experiencing winter, E is experiencing summer. So they're not going to have the same season. Will they have the same local time? Well, yeah, they're on the same longitude line. So if it's noon at B, it's also going to be noon at E. So it seems like number 2 is correct. They have the same prevailing wind direction. Nope. Winds vary. We've seen that. That was in our previous unit. Remember, the winds vary depending on your latitude. They change, right? They're at the same latitude. Nope. Latitude lines run laterally, like lat. So latitude lines, the equator is a latitude line. This is a latitude line. They are not at the same latitude line. Okay. Like Tropic of Cancer is a latitude line. So the correct answer has got to be number 2. All right. Number 36 is also based on this diagram. The latitude and longitude of which location are closest to those of New York State? All right. So we know New York City, New York State, we're at around 40, 45 degrees. So it can't be A. That's too low. It can't be E. That's in the southern hemisphere. So I know it can't be A. It can't be, E is not even a choice. B, C, or D. Let's see if this is 30. 40 is probably right about here. 50 is probably right about here. Oh, D is on 60, so that can't be it. So it's got to be either B or C. So now I need to know, well, what is my longitude? And the best way to do that is to look at page 3 in your Earth Science reference tables. So this is page 3. So the numbers that are showing up all around the edges here, these are latitude and longitude numbers. So these are our latitude numbers because they're increasing as you go up north, right? So here's 41 degrees, that's New York City. 42, they're increasing as you go north, so I know those are my latitude numbers. And then the other numbers are our longitude numbers. So 74, 75, 76, 77. You can see that they're increasing as we go toward the west, which to me means we must be in the Western hemisphere. So these are Western longitude numbers. So if I go back to my question, it says, oh, right, I'm covering it up. We're looking for some number in the 70s. And so that means it can't be B, right? Because B is in between 90 and 120. This is the 90-degree longitude line. Here's the 120-degree longitude line. Here's the 60-degree longitude line. So that means the correct answer has got to be C. We haven't talked about that too much. We haven't really officially learned about latitude and longitude, but sometimes you can figure those things out. All right, let's take a look at 39 and 40, the last 2 questions. What time is this time? What is the time in San Francisco when it is 6 a.m. in Dallas? All right, so where's Dallas? So at Dallas, it is 6 a.m. All right. And we're looking to find out what time it is in San Francisco. So Dallas is here, and these are time zones. So it's 2 hours off. If it's 6 a.m., and I know that as I go towards San Francisco, it should be getting earlier in time. So it's got to be 2 hours earlier, which means the correct answer has got to be 4 a.m. Okay. That's from your Earth motions notes again. Okay. All of our time zone stuff. And finally, number 40, the dashed boundaries between time zones are how many degrees of longitude apart? Well, each line is 1 hour. And we know that time is based on Earth's rotation. So 15 degrees per hour, which means it's got to be 15 degrees of longitude. Okay. I hope this was helpful, and thank you so much. Bye.